Hi everyone, I'm Kirill. I'm doing the Scala development at the Spot Trader, and I guess you all are quite tired at the moment. So we're gonna have just a nice roller coaster ride. For those who don't know what that figure is, that will be the last slide. So fasten your seatbelts and just enjoy. There are not gonna be a lot of heavy things, I promise you. So, practical usages of the macros in Scala for smooth development. Let's define what we call smooth in fact. What it is, for me, smooth is when we don't have stupid mistakes. Stupid mistakes are typos, stupid mistakes are resource leaks, stupid mistakes are about locks, are about many simple things. If you do some stupid manual JSON serialization and you forget to close some object, that's one of the things I don't like, and I think that's the mistakes which can be easily avoided with some effort. One of the reasons and one of the ways we can avoid it is just macroses, because why not? We can do the code generation, we can do the static checks for today. Early in the day, there were the static checks for the regexes and stuff. What else? Yeah, some domain-specific languages, but that's interesting, but I don't know, that has to have a big goal or aim. Introducing DSLs is always a strange thing. But yeah, anyway, a lot of those things you could have heard from the Eugen's talks starting from 2013, 2014, and so on. So, back to the good old days, and those days are still our current days, in fact, because the first implementation of and support of the Scala macroses appeared in Scala 2.10. It is experimental, it is still experimental, and it will be experimental, but how many projects do you know that are using macroses, like production-ready projects? No? No? None projects? OK. At least today's totalitarian. It's maybe not yet production ready, but it's one. Don't forget the SBT, which is using it just all around the place. Also cats, they use macroses as well. What else? But the old legacy, nice, and the only macro implementation which is available at the moment, it's a pain in the because it's hard to troubleshoot, it's hard to debug, and it's really IDE unfriendly. Because as it was said already, the IDE is bleeding. Not only IDE, my eyes are bleeding as well when I sometimes have to deal with the macroses and the IntelliJ. And the last thing, yeah, we can use them right now. That's the main benefit. That's the tool you can use at the moment. Because it's nice to have some tools which will be available, but you need something right now. And in the year of 2014, there was the Scala Meta announced by Eugen on the Scala Days in Berlin, as far as I remember. And it's going to be production ready one day. In fact, as far as I know, the current schedule, they plan to productize it by the end of this year. So hopefully that will happen finally. That will be really nice. And now Scala Macros is under the wing of the Scala Center, as far as I remember. So we'll see. And the nice benefits are that Scala 2.x will be supported, Dotty, and IntelliJ. Finally, we will get some IDE support for the macroses. And yeah, let's wait for the end of the year. Just 1 month left. Fingers crossed. But who cares about the history? We only care about the things we really do, because the tool is not here yet, so what's the point? What actually macroses can help you with, that's one of the things I've already been telling you, and yeah, eliminating the resource management bugs, those stupid things, and Java was fast enough to realize the problem and introduce those famous try with resources. Well, it took them many years to realize, but at least they introduced that. Unfortunately, in Scala, we don't have such premium things. So we have to manage those things on our own. And it's always very, very disappointing when you find out that, oops, it wasn't closed. We have a resource leak here. And it happens in many projects. There were resource leaks in Akka as well. And also there are some nice libraries, like I have nice experience with the rabbitmq library they provide, and they are not really implementing AutoCloseable even. They have their own hierarchy, and they just have a close method, which can be also, in fact, work out with the help of the macroses, because you can just check if it has a closed method. That's the first small snippet of the code. In fact, it's back from the 2014, I guess, as well. There's the simple implementation of how you can just implement a kind of try with resources. One of the questions I always hear is, why should you do macros when you can just use a function one something? Well, because of allocations, because sometimes it really matters that you don't do allocations, you don't grab the auto scope, and that you do just things in place in a rather brutal or simple way, but still. That's mainly it. And I won't be really digging into the writing the macroses, because it's a quite hard path, and not all of the things can be easily explained, let's put it that way, and in the legacy implementation, some of the things just exist. And deeper you go, less documentation you get. That is as well here. I can leave it for some seconds for you to meditate if you want. Let me see if you can. No, I can't zoom it really. Too small? Sorry about that. What else do we have here? That's true. Is it? Oh. Yeah. One of the things also is just simplifying the boilerplate code. For example, I don't know, yeah, the manual JSON creation, because sometimes you have to, for example, use JSON, and sometimes you really have to write the objects using those glorious start object, and you definitely need to put the end object. And one of the most disappointing things I also found one day is that someone missed the end object thing. So it wasn't possible JSON, just out of the thin air, just because it's hard to actually find where it should be closed and stuff like that. What else? Yeah, and my favorite thing. That's the most powerful part of the macroses, but most of you should know that as well. That's the code generation, because one of the classical examples is that a case class, for example, is enriched with the method to map when all the fields of the case class are gathered into the map, some kind of map string to any. Yeah, and one of the things we actually are using is just generating the class hierarchies and the wiring using the macroses. And we use for that the, I would say, the most needed things like quasiquotes, because writing the ASTs on your own is not the best and the most pleasant way. Quasiquotes just come to the rescue. And the paradise, because paradise gives you the macro annotations, which are also nice things and which are actually helping to enrich the classes. Yeah. So with that great power, we can do something. Actually, something is depending on what do you need. We need it mainly for the complex data structures when we have multiple entities which are combined in, for example, partially persistent general trees. So, just to make things a bit more simple, partially persistent general trees. Partially persistent means that you have read access to, versionable trees, sorry guys, that missed on the slide. Partially persistent versionable trees means that you have read access to the history of the changes of the tree or a particular node in the tree. The fully persistent means that you can also do the write operation, so you can have that version as a kind of milestone, and then you have two parallel versions of that tree. But for simplifications, it's easier to use the partially persistent trees. General means that it's not binary tree, it's just a tree with the unlimited number of children and unlimited height of the tree, or depth. Yeah. And for the sake of the performance, references to parent and child or children are containers. In fact, there are a couple of options how to make versionable trees, and there are some papers regarding that topic, but to be honest, from all those papers, there are mainly two of them. One is proposing the container option when a node in a tree is not actually your immutable object, but it's a container of the versions, like, you know, a sequence of the versions, and the relations between the parent and the child are tied to the containers themselves, not to the immutable objects. The other approach is when you have the completely immutable tree, but that comes with the price, and I think the next talk is about complex immutable objects and stuff. Anyway, the quite complex immutable trees have their own performance issues, so that can also be, what else? And what can we make of the macroses here? So we assume that the nodes of our partially persistent general versionable tree are the entities. And for those entities, we can have, in fact, a lot of boilerplate code because, well, we have a concept that the whole data is immutable, but it comes always with the price of the performance, or memory or performance. Memory is mostly can be compensated by the memory sharing, but performance for copying the immutable objects is not that easy, especially when you have bidirectional relationships between the nodes. Sorry, I got some water. So the implementation we have and the concept what we use is mainly driven by the performance in the concurrency. And let's use three main terms here. Immutable, it's a really immutable entity, which it's immutable, that's it. And it's accompanied with the mutable entity, which in fact has all the same fields, but they are mutable, they are vars. You can operate on them, do whatever you want, but it won't be stored in the tree anyway. Only immutable objects are stored in the tree. For the version transitioning, we are using so-called deltas. Delta is a specific object containing the changes from state 1 or state A to the state 2 or state B. So it generally contains the fields that have changed in a compact way. So that guarantees us that the transition from one state to another state can be as compact as possible. Yeah. And kind of simplifications that we use in that context. The node in our entity in general is just a trait. So we're declaring a trait, and we annotate it with the macro annotation. That's it. All the other magic things are happening with the help of the macros. Immutable is a case class because just case class gives us some hash coding equals foo is getting tricky there, but it's easier to have it as a case class. And mutable is just a simple class because you shouldn't use mutable that many except for the actual mutations for the nodes of the trees. That said, simplified transformation for the entity are, there is some function that transforms a mutable object into immutable representation, and vice versa. An immutable object of the state A plus the delta of the state B produces an immutable state B, which is pretty logical, in fact. What else? And I think there should be... Is it difficult? Or not? I'm just interested in an honest opinion. It's a bit of math. It's not something really cerebral. So it's a kind of complex data structure for me. That's one of the snippets, for example, which we are using. So you just create a trait, annotate it with the macro annotation. We have additional annotations for the fields. They are compile time. They are used to be able to produce the compact formats for the serialization and deserializations. So the macros not only generating the immutable case class, mutable class, delta class, all the wiring that is needed to transform from the other state to the other state, from mutable to immutable, from mutable to immutable states, how to apply delta to the object. It also does the serialization wiring in the compact form. And yeah. Oh yeah, and one of the minor things that if for some reason you need a companion object, you have some nice methods there. Yeah, it's okay, it will be just extended. If it doesn't exist, it will be created automatically. It's no big deal. Yeah, I'm lazy. And really when I was preparing the talk, I was thinking about, yeah, we can dive into the macro details, but guys, the real implementation is about 1K lines of code, which has many corner cases of the macro implementation taken into account. And generally, I can't say that it's fascinating to dive into it, because my main point about using and writing the macroses is something you write once, see that it works, and mostly you won't touch it anymore until you have a real need to extend it. For example, the AutoCloseable example is really about how many years? 4 years old, and I didn't really touch it except for some minor input changes that were made in the Paradise and black box context back in the days. What else do we have? Yeah. Yeah. So what we actually are achieving with using the macro annotations and macroses is that we don't have boilerplates. We minimize the amount of typos we will have, because all we have initially is a trait with the fields declared. That's it. It's hard to make a typo there, honestly. we don't need to spend additional human hours when we will need to get new entities for the trees, because all you need to do is to describe your domain-specific object and annotate it, and you will get all the wirings, all the things out of the box. Yeah, and you really won't be changing code generation implementation really often. It's happening so rarely. But there are always drawbacks. One of the drawbacks, except for the supporting the IDs and the debugging problems and the lack of documentation, is that the compilation time increases. That's one of the problems. It takes time for the Scala C to do its job. Well, yeah, because macroses should be expanded. There's nothing we can do about it. You have to accept it, I guess. And the other thing is SBT related, because since SBT 013 I don't remember, 1x, or something like that. Anyway, they will trigger the recompiling of the code which contains macroses unconditionally, so it will be recompiled almost always if there are some changes. But that's one of the things that they introduced at some point, and I do understand the ground of it, because tracking down the changes in the macroses is not trivial at all, especially with the current support. Hopefully it will get way better with the Scala method tools under the hood. But currently, yeah, you will have some additional time spent in the builds, that's for sure. On the other hand, that time is way less than you can spend doing the boilerplate code or trying to find the typo in your code, if there is one. What else do we have? Yeah, and that's for the graph I had. It's, in fact, Euthanasia Coaster. It's a state-of-art concept. I just added the description. Hopefully it's not small enough. I would say that the whole experience with the macroses at the moment can be applied to that graph. Because when it was initially presented to the public, all the interest went pretty high. But then, because of the complexity and the additional effort needed, the interest got to the lower point. And now we're just in a circles. So hopefully we'll see the Scala meta, because without it, it's getting really painful at some point. That's generally it, because I really don't want to... Well, when I was preparing the talk, I just looked at the time and said, no, nobody's really be fit enough at 5 p.m. to do some really hardcore things inside the details. But if you wish, I can try to show you something, if only you wish to meditate a bit. Do you have any questions? Any? Some? None? Because I think I made it really fast. Yeah, twice as fast than I should have. Yeah, really one of the things about the macroses is that some of the tricks you can't find in the documentation, you just have to Google them. At least it was back in the days. Nowadays it should be a bit easier, but some of the things, nah, it's not working out. So I can't really say that you should avoid macroses at any cost. No, you should consider the usage of the macroses responsibly. But that's true for any tool anyway. So that's it from my side. I hope the ride was pretty smooth. You got some rest and relaxed a bit, because there is only one more talk left. So soon it's going to be over.